Hello and welcome to the first lesson in our training program, Intro to Electrical Theory. So there's going to be many training modules, but this is where we're going to start and let's see how far we get. So the first thing that we need to understand is a phenomenon known as charge. So charge is the property of matter that causes it to experience a force when placed in an electromagnetic field. Subatomic particles are the shall we say, elementary piece of matter that we observe this phenomenon in. So I guess we should start with a model of such particles. So here we have the Bohr model of an atom. This isn't the way that an atom is actually laid out, but it's a good way to look at it for our needs. So the nucleus of an atom, you're probably already familiar with this layout, has neutrons, which have no charge, protons, which have a positive charge, and electrons, which have a negative charge. So we're going to be primarily dealing with electrons throughout this uh, course of lessons and how they behave in these circuits. So when we're talking about charge, we could, if we were so inclined, refer to the amount of charge that a single electron has. But that amount of charge is far too small for the applications that we're going to be dealing with in actual practice. So we use a different unit, and the unit that we use is the Coulomb. So when we're talking about charge, the symbol for charge is a Q. The unit of charge we're using is a Coulomb. The symbol for a Coulomb is C. And a Coulomb is the amount of charge which equates to 6.24 times 10 to the 18th electrons worth of charge. So a substantial amount of, it could be protons too. They have the same relative charge to each other, but this is how many electrons worth of charge a Coulomb worth of charge is. And when we talk about charge from now on, we'll be referring to it exclusively by the Coulomb. So you're probably already familiar with the concept of charges attracting or repelling one another, but just as a quick refresher, um, positive charges attract negative charges, and negative charges attract positive charges. But if you're ever in the presence of a positive charge and a positive charge, they are going to repel each other, as will a negative charge and a negative charge. They will also repel one another. The next concept that I'm going to expose you guys to is the concept of a voltage. So a voltage is the electrical potential between 2 points. The between 2 points here is important. When we talk about electrical potential, we're not talking about an absolute value. It's difficult to point at a spot on a wire and say, what is the voltage here? We are often the only really appropriate way to talk about voltage is a voltage between 2 points. The way to think about this is how much electrical current wants to flow between 2 points. If you imagined a circuit like a pipe with water in it, voltage would represent the pressure, the water pressure, how badly it wants to flow. It doesn't necessarily mean that any current, or to continue with the metaphor, water is flowing, but it's how badly it wants to flow. When we talk about voltage, we are going to refer to it with the symbol E, and it is measured in the unit volts, which is represented by V. Okay, so if we were to look at a voltage, it would say 120 V, for instance, and that would mean 120 volts. But in equations, we're going to refer to it with an E. Next concept I'm going to throw at you guys is the idea of current. So current is the flow of electric charge. So this is how much charge is flowing over a given point at any one time. So if you want to continue with that metaphor of a pipe, voltage is the water pressure and current is how much water is flowing at that moment. Okay, so if you have a pipe, you could have a little bit of water pressure, but a lot of current flowing if the pipe was very large. Vice versa, you could have a lot of water pressure, but very little current flowing if you had a very closed valve. So while these are related to each other, they aren't equal to each other. They're two different things. Current is how much charge is flowing down a wire. Voltage is how much potential there is, how much that voltage, or sorry, how much that current wants to flow. When we talk about current, we are going to use the symbol I to talk about current, and the unit for current is amps, measured or represented by the letter A. Now an amp is 1 coulomb per second. I'm just going to add that in real quick just to show what I'm talking about. So an amp is equal to a coulomb per, oh, beautiful lettering, second. Okay. The last concept that we need to add in here is resistance. So resistance is a material's opposition to the flow of electrical current. Okay, so a low resistance in a material would represent a good conductor. It means that for a given voltage, you're going to have a lot of current because the material's opposition to the flow of current is low. This concept is expressed in our first equation that we're going to use, and probably the equation we're going to use most often, and that is Ohm's law. I'm going to make this much bigger because of how important it is. Ohm's law. So Ohm's law, okay, is current between 2 points is equal to the voltage between those 2 points divided by the resistance between those 2 points. There's sort of an intuitive understanding here. The current that is, oh, I almost forgot, just a sec. When we talk about resistance, the symbol for it is R. It's measured in ohms, and the symbol for ohms is this omega right here. Okay. Again, Ohm's law states that the current between 2 points is equal to the voltage between those 2 points divided by the resistance between those 2 points. Okay, so if I have a given voltage and I have a very low resistance, you can imagine the current will be very, very high. Conversely, for a given resistance, if I have a low voltage, I'll have a lower current. So while current and voltage are linked, okay, they're not necessarily equal because I can have a very high voltage, but if I have a really high resistance, let's imagine a power line, those have very high voltages on them, but the resistance to you on the ground is very low, or very high rather, very, very high, thankfully. No current from the power line is flowing to you. That's why you don't just die when you come near a power line. So this concept here, Ohm's law, is pivotal for this lesson. So in summary, we have charges that we observe in material. We measure those charges in coulombs. There can be an electrical potential between 2 points, okay, and we'll discuss in the next section how that occurs, like where that comes from. And this is the basically electrical pressure is a way to think of it, the degree with which current wants to flow between 2 points, okay? And current is the flow of electric charge, okay? So it's how many coulombs, let's say, are going down a wire per second. And resistance of a material is how resistant that material is to that current flow. So if I have a given voltage between 2 points and there is a resistance between those 2 points, a current will flow that is proportional to the voltage and inversely proportional to the resistance. And in our next section, we'll see some applications of this. Catch you in the next one.